Supposed to be tight, but go ahead. It's not supposed to be loose when you wear it.
How was your weekend? Good? Tired? No? It's chilly.
Okay. So looking into the rest of the week, or this upcoming week, I should say, we're kind of reviewing some stuff about car wheels and rotations and circumference. Tomorrow, we're going to do a big review of everything we've done so far with all of this circle stuff. Wednesday is just your makeup work day, so it's not going to be a live class. But then on Thursday, there's going to be a quiz. So all of the stuff that we do tomorrow, the review that we have, everything that we've done, quiz on Thursday. Friday, move into, we've done circumference of circles, we're getting into the area of circles. This is an AirPod, however, I do have it printed and I'm going to be on this. Your homework is, this is the table because your homework is the last page. We're not going to end up going through all of this. I redid it last period and there were some questions that I just didn't like. So we have example 1, example 2, example 3 we're not going to do. So that means some of your homework questions are going to get simplified too. If you remember this. Yeah. We are going to need some calculators. So pass this out. Everyone wants one to let you go. Is that not working? Did you die?
I don't know.
Do you want to pencil?
Yes,
You can
please.
get one out of that. So we'll do this when you come back, 10th period or 9th period, depending on how much we get done today. I'll go through your homework with you because I'm not 9. And then you're gonna work on those projects that we started last week. So those career projects, some of you are already done with that, so you're gonna have something else to do. But that's our goal. We're gonna finish those next or by tomorrow. Okay, so you can take a minute, fill in the blanks. Those of you at home can log in and follow in the Nearpod. So it says the circumference of a wheel can also be thought of as the distance the wheel travels in one rotation. So we talked a little bit about this on Thursday, and then we changed gears on Friday. But whenever we're talking about something spinning or we're talking about how far a car is going, you're looking at the rotation of the wheel, and that's just different language for circumference. Through this whole sheet, we're going to do a lot of time conversions and distance conversions. We did a little bit of these again last week. But I just want you to have them on your paper so that we can remember them. How many minutes are in an hour? 60. Simple. How many seconds are in a minute? 60. Right. So we want these so that later on in the work it's a little easier. So then how many, so 1 hour equals 60 minutes. Let's put the other unit here so it makes sense. 1 minute equals 60 seconds. How many seconds are in an hour? Shouldn't need a calculator. How many seconds in an hour?
36,000.
60 minutes times 60 seconds, 3,600. You got an extra 0 on there. But we are gonna use those throughout these problems. A couple of these are gonna ask us to convert seconds to hours, so you would divide by that scale factor. We can think back in terms of unit 1, hours to minute, your scale factor is 60, minutes to seconds, your scale factor is 60, hour to seconds, your scale factor is 360. So we have our distance conversions. Anybody remember what we said about how many feet are in 1 mile?
300 to 180.
Ah, so close. 5,280. I'll give it to you. 5,280 feet. How many inches are in a foot? 12. And then how many inches are in 1 mile?
63,360.
She's just multiplying these. If there's 5,280 feet in 1 mile and 12 inches in a foot, you can multiply them. Again, those are just our scale factors. So if we have to go back and forth between miles and inches, our scale factor is 63,360. Feet to inches is 12, miles to feet is 5,280. Again, we just want to see those so that we don't have to keep doing the same math. Obviously, some of them we know. I don't expect anybody to remember that last one. So we have example 1 saying that the circumference of a car wheel is 65 inches. If the car wheel rotates once per second, how far does it travel in 1 minute? So with all of these distance and speed problems, we're going to start with big tables because we should be comfortable from unit 1 and unit 2 doing like a proportional relationship table. So filling it in, finding your scale factor from left to right. So we're comparing 3 things here. We have how many times it rotates, we have the distance it's traveling, and we have time. So once I fill that in, what do we know about the car wheel? Before we even do anything. Gwen?
65 inches.
What's 65 inches?
Car
Right. The circumference of it. And again, the circumference of it, that is another language for telling you in one rotation, how far is it going to go? So that first sentence that's talking about the circumference tells you how far it goes if it spins once. I also know that it rotates once per second. So it spins once, it travels 65 inches, all in 1 second. So I can fill that all in. I need to figure out how far it goes in 1 minute. So we want to pay attention to the units that are in our table. So if we're in seconds here, if I'm looking for 1 minute, how many seconds is in a minute? So I'm going to put a 60 at the bottom of my table. I can think in terms of scale factors. 1 second times 60 gets me to 60 seconds. So if I'm looking for how far it travels, I'm looking for this number here. So my same scale factor, multiplied by 60, what do we get?
3,900.
And we're in inches. So if you organize it into a table, put in everything that you know, think in terms of your scale factors. You can find your scale factor up and down, like I just did 1 times 60 was 60. You can also go left to right. If I go 1 second to 65 inches, that's a scale factor of 65. You could also do 60 times 65 to get over there. It's all the same thing. Part B says the diameter of a car wheel is 36 inches. If it rotates twice per second, how far does it travel in 1 minute? Can I erase this stuff so that I can speed the problem up? Is anybody still looking at this? Because I know now at this point we can't see. So this is similar. The only difference is that we don't have the circumference, we have the diameter, and we have that it's rotating 2 times instead of once. We're going to do it the same way. I just want to be able to see. So the diameter of the car wheel, 36 inches. So if we draw what that looks like, here's your wheel. What's your diameter? Or where's your diameter? Straight across the center. This is what, 36. If we're talking about speeds and rotations and distances, you need to know the circumference. How do you find the circumference if your diameter is 36?
3 times 36.5.
3.14 times 36. What's the circumference, Brooke?
113.04.
So we have to do that step first. That tells us how far the car goes if it spins once. Now we can make the same type of table that we just made so that we can just organize and see the numbers better. So we want to talk about how many times is it rotating. We know some information about the distance, and we want to know some information about the time. So circumference and distance, they're interchangeable words. Means the same thing. So put my circumference in my distance column. And again, that's how far your car goes if it spins one time. Circumference is always one spin, what's the distance? But what do I know about the car? How fast is the car will spin?
Twice per second.
Twice. So I'm not necessarily interested in 1 time per second. I want to look at if it's rotating twice. So how do I figure out the distance? It goes in 2 rotations. Multiply by 2. Again, scale factor, 1 times 2 is 2, so I can do that same thing here and do 113 times 2. Oh, thank you, Parker. What a guy. Sorry, guys. Oh, we're still on the same page, Parker. We're down at the bottom. You're down on B. I just scooted it up. What'd you get?
226.08.
Exactly. Okay, 226.08. Okay, so that's how far it goes in 1 second. We're pulling that straight from rotates twice per second. So 2 times, 2 rotations, it travels 226 inches per second, means 1 second. Once you fill that whole row in, it becomes very easy. Because now I'm just looking for 1 minute. So just keep the knowledge of what unit we're in. And if we're looking for 1 minute, how many seconds does that mean we're looking for?
60 seconds.
60 seconds. So I'm going to fill a 60 in down here. Now you can easily see what your scale factor is. And again, it doesn't matter which way you go. I just noticed that 1 second times 60 gets me to 60 seconds. So my scale factor vertically is 60. So I can take 226 times 60. What do you get?
13,560.
Is that right? Is that what you said?
Yeah.
Okay. The decimals, I'm not gonna be too picky about writing them in. It's hard to hear you guys. And if we're talking about an inch, like 0.04 of an inch literally means nothing. So we're just gonna stay with that. So then again, found for 1 second. If I'm talking about a minute, that's 60 seconds. That scale factor is 60. So then altogether, we go about 13,564 inches. You organize it into a table, it makes it significantly simpler. You can see all of your numbers, you can figure out what all of your scale factors are. We go with that. Try to get started on C on your own. Slightly different. Now I will change the screen because now we're on the next one. It says the radius of a car wheel is 1 foot. If the wheel rotates once per second, how far does it go in a minute? We start with your picture. You're only given the radius. Try to fill in what you know about your table. What do you know about the rotations? What do you know about the distance? What do you know about the time?
I probably know if you're doing your times by first. I'm going to do times by 2.
Okay, you're given the radius first. Instead of that. You want that? What? I'm listening to you.
Friday and Tuesday online. Me and Levi had Miss Myra,
Okay.
and now do we have Steam?
Oh, I have no idea. I can look at your schedule at the end of the period.
Yeah, Steam is there.
I'll look at it before the end of the period if I forget, remember, or remind me. I have no idea though. I don't know what your schedule's like. And you guys are not all in the same place now, right? So it's not even benefiting you to ask. Okay. So I'll look it up. I have no idea. Does everybody else know where they go next period?
I do.
Does anybody know if you have the same classes RJ next period? I'll look it up. I'll figure it out. So what do we have to do first? If I'm given the radius,
Times radius by 2.
to find the diameter. So that means my diameter would be 2. And then what do you have to do?
Times 2 by 5.
Because whenever we're talking about distances, different language for circumference. So we need to find the circumference.
I know the answer.
What is it, Parker?
6.28.
Exactly. So the circumference is 6.28. So all that tells you is that if the car spins one time, it goes 6.28 inches. Is it, how many times per second is the car rotating? Right. So we're pulling all of that out to fill it into the table. Once per second, rotating once, traveling 6.2 inches in 1 second. How far does it go in 1 minute? 60 seconds in a minute. So then how do we finish it out?
6.28 times 60.
Okay, because my scale factor, 1 times 60 is 60, so 6.28 times 60. How far does it go in a minute? Or,
Because you're at 76.8 inches.
exactly. Organize it into the table. It declutters all of the confusingness that you're reading through. You can quickly see your scale factor. Again, you can find scale factors up and down. You could also say 1 times 6.28 is 6.28. So 60 times 6.28 is going to give you that same answer. It's all the same thing. Okay? Are we good with that?
Yes.
Only other example we're doing is 2. Like I said, we're skipping 3 because I ended up not liking it.
This is confusing.
You don't need to worry about it right now. I said I'll figure it out for you whenever we're done.
It is, it's amazing.
I know.
I'd rather do this than do this.
Example 2, now we're talking about just converting from miles to hours, or miles per hour. So before we were in inches per second, now we're looking at everything and figuring out how many miles per hour it goes. So example 2 says that if the car from example 1A rotates once per second, it's all the same information from above, how many miles does it travel in 1 hour? So we're gonna start by just rewriting the stuff that we know from what we just did. So we did time and distance. So we just figured out in 1A. So from 1A, if you look up, we figured out how far it goes per second. So we know, so we know that in 1 second, it goes 3,900. We're just rewriting the answer that we did in part A. I need to figure out in 1 hour. I screwed this up. This is minutes. Ignore me. Minutes. So in 1 minute, sorry. In 1 minute, the car goes 3,900 inches. If we're looking for hours, what number should I put in my minute column to scale it up to an hour? Gwen? Right, because there's 60 minutes in an hour. So I'm gonna scale this up, 60 minutes. This is in inches. So I'm gonna scale this up. How many inches does the car travel in 1 hour? Don?
23,400. Well, 234,000.
Mm-hmm. We're good. So I took care of the first part. I figured out in 1 hour. Because I took what it did in a minute and I multiplied it by 60 because there's 60 minutes in an hour. The only other part we have to figure out is that we're not looking for inches, we're looking for miles. So in the table that we wrote at the beginning of class, what scale factor takes you between inches to miles? What's your big scale factor number? Inches to miles. What do we say at the beginning of class? We can look in this chart, in the distance. What's your inches to miles scale factor?
63,360 inches per mile.
Right. So if that's how many inches are in 1 mile, if I have 234,000 inches, finish it out by dividing by your same scale factor. Inches to miles means take your inches to miles number, 63,360. How many miles?
Okay. 1 mile equals to 440 inches.
Just take 234,000 divided by 63,360. What do you get?
3.6.
About 3.7 miles per hour. It's all the same things that we did in unit 1 that we did in unit 2. Just finding your scale factors. If you're finding it and organizing it into a table, you can see what they are. I had to scale minutes up to an hour. My scale factor from minutes to hours is 60. I had to scale inches to miles. My scale factor taking me from inches and miles is 63,360. We're gonna do the same thing for B. It says pull out your information from 1B. So the second problem that we did above, we found out that in 1 minute, the car traveled 13,564 inches. Again, I'm not including the decimals because it doesn't really matter. That's what we know. I need to figure out how many miles in 1 hour. So do one conversion at a time. How many minutes are in an hour? 60. So that means if I change this to a 60, and I scaled by 60 here, I scale by 60 here. So in 1 hour, how many inches do we have? What?
8,138 and 4.
Something like that, right?
Yeah.
So that's how many inches in an hour. So we took care of the first part of the conversion. Miles to hour, we took care of the hour part. Now we just have to worry about the miles. So I look at the unit that I'm in, inches, I have to go to miles. So what scale factor takes me from inches to miles? Same one, 63,360. So take our big number that's written in inches, divide it by the scale factor. And how many miles do we get? Twelve point eight. Try to do the next one. If the car wheel from 1C rotates once per second, so I'll pull out that information from you. So from 1C, we knew that in 1 minute, the car traveled 376 inches. How many miles does the car travel in 1 hour? So that's what we know. I know how many inches it goes in a minute. We need to figure out how many miles it goes in an hour. Try to see if you can go through the same thing we just did. Take care of your time conversion first, then take care of your inches to miles conversion. I think they're both right on that.
Yours is not her. Again? Yeah. You're for all quarter, third period. Term 2.
Mm-hmm.
I don't get this.
It's in 9-week periods. Do you know how our classes changed last week?
Because we're in the second term. Okay, so then.
So this is, you're looking at this until January. Let me look at this one.
So the January.
So the second quarter ends, January 26th. Don't get any of that, I'm not gonna scratch it out yet though, because
So
you're gonna need it.
this is all for 9 weeks. Okay, so then after today, tomorrow is.
Yep.
Yeah, okay. I said, so after her, tomorrow till the end.
Okay?
My brother told me.
Just take it.
It's a bookmark.
In 1 hour, what do I do?
Okay, so what am I supposed to do here?
We're gonna do it right now. We're gonna do it. How do I figure out how far it goes in an hour? When?
You go 3600, that's how many seconds are in an hour, and you times that by 376.
So 1 minute, 376 inches, 60 minutes in an hour, times by 60 here. How far do we go in an hour? In inches.
I was in second.
Oh.
That's what it rotates. So it says it rotates once per second, but then we already figured out in question number 1 what the minute conversion was. So you probably you probably just redid the same work that we did.
Yeah.
Jordan?
Right, 21,600.
21,600. So again, first part, that is how many inches it goes in 1 hour. The only other thing that it's asking us about is we don't care about the inches, I care about the miles, because when I'm going down the highway, everything is in terms of miles. So then what do I have to do to convert my inches to miles?
I'm gonna say times it or divide it.
One of them.
Times it? Oh, no, divide it.
Right. So 21,600 divided by how many inches are in a mile, use your
Now.
scale factor, 63,360.
Yes, it's equal.
How many miles do we have?
Yeah, isn't this almost over? Because I was gonna ask for a calculator.
This is the last thing that we're doing.
No.
What we get?
0.03.
What's this?
0.03. So really not moving at all. Maybe you're stuck in traffic. You're not gonna click, right? So again, main idea, circumference is the same thing as distance and rotation. Put all your information into a table so that you can organize it and get rid of all of the clunky words and figure out what your scale factors are. Okay, we are not doing example 3. So if you look, flip your page, you can skip out everything on example 3.
Wait, flip my page.
I'll give you it in a second. We're not doing example 3. What I want you to do right now for the last 10 minutes is A, B, and C down where it says your term. You're just working on A, B, and C. You're not doing D, you're not doing E. That's all we're doing for the rest of this period. Skip example 3. Those of you at home, I'll flip so you can see what we're doing. Skipping this one, so you're just working on these last 3 problems. You guys are skipping D and E altogether, skipping example 3 altogether. Exactly the same stuff that we just did. So you might get
That's not.
This sauce was spicy.
It's all about that game. You guys love that game. I don't know. That stupid game.
No, not that, the other game. The little like character.
We gotta figure out who did something.
It's like murder mystery, but I bought skins. I bought skins. I got a gift card for my birthday. Well, not my birthday. Huh? You have skins.
I have a rainbow skin on it.
I think I'm gonna do No, I literally bought skins, I thought,
So
the
come
pet bundle was just
So start with
ticket
the
fees,
yeah,
I
we
thought
like
they
there's three.
And
Things. Draw this table, Parker. Rotate distance time.
No, you should really.
Draw that. Fill any numbers in, just draw the table.
Is when.
What's the scare tag?
It's
What's the scare tag?
For what?
For robot,
8 and 4.
8 and big 4.
Eight, on like eight.
Okay, write that down so then I can report it
So the
on.
circumference is 70 inches. So that's how, so when it
Well,
rotates,
it's like you learn all that money that the most spent
so it
on
rotates
the
once
weights
per
or
second. It rotates once.
No, no,
Per
no.
second.
Okay, so Leva, we have Miss Niagara for 9 minutes.
Yeah, I do that.
I hate you guys. She has a racist.
70 inches.
Miss Niagara, Miss Niagara, Miss Niagara. If I keep saying it over and over and I get say Miss Niagara over and over. That thing. This
You need to
is
figure out
bad.
how far it goes in one.
Okay, where should I spend money on Roblox for you?
Seconds.
Over $75. Got flexible.
That's $1 million.
Yeah, and I spent my money on the Cold War. You want it? I can give you the Cold War game so you download it.
Like,
One time.
You want it?
that's.
Right. I want to see it, right?
Levi, I swear to God.
70 times what?
Levi, I'll try to gift you it.
I really,
Like the bay.
I need that.
But I will try to report to him, so he uses all his time and all that scanning and stuff, their stuff that. And if you don't send one back, or stuff, I will report you. Oh, like, so what?
That's disgusting.
I won't, it's not disgusting.
I only did in a mile.
Yeah, and I bet you don't.
So another thing now is that rotation distance.
I only did in a mile.
Among Us.
I said, come here, let's do electrical together.
So now I'm asking you, how far does it go in one?
Forget Aiden, does he have a bank account with nothing on it? And your brother.
You report me.
We're gonna do, especially for ladies.
Yeah.
RJ.
Okay, so I'm gonna cut you. It's hard because.
I don't feel like it's like 15 years.
Officially like.
The reporting.
What's your official ticket for Asia Minor?
You're just doing A, B, and C.
That's messed up.
How many miles does it travel per hour?
So we were.
20 minutes.
And also, 74 minutes. The Eiffel Tower.
Oh, that's
Not ever. Because I knew 74 that 9/11.
What the 9/11 that you did was that.
Look at Aiden's face. I said before, you know, I did 9/11. That's what I mean. Wait, my bike came.
RJ, your ears remind me of Dumbo the elephant.
Thanks. We said I could fly. I gotta touch the top of your forehead. It's endless. Your forehead is like the endless pit of pasta at Olive Garden.
So funny.
Your forehead's like the endless pasta at Olive Garden. No.
I know, right?
You can read it.
You're like a goblin from Lord of the Rings.
So this is your minute.
Hey, I'm telling Papa Smart if I like to do this.
I'm 60.
Shorter.
Bigfoot.
Hey, can you tell him Jim?
RJ, can you get Bigfoot? RJ, can you get Bigfoot's shoe back?
Huh? This is how big of a knowledge.
So that's how many inches it goes. Right.
What's your number? Your lowest number.
One second.
You don't have to serve. What?
Divide to get down to 1, so you're gonna divide.
Like a DJ or let's get time off back to go on. That's what Austin says when he says it. I know that taking time off. Wow, I'm not joking about him having a girl shit.
This is how much.
I'm not joking about him having girl shit.
Nice highlighter is sponsored.
Actually, they're not that bright anymore.
They are.
Okay, I'll snap your crayons in half here and stop it. I'm serious.
I snapped that to the forehead.
It's like the Eiffel Tower. I can visit Paris in
In a second. So you just wanna visit the Eiffel Tower in a second?
Okay, so there's a couple minutes left. It's okay, I'm not doing anything, I'm just explaining. Just talking. Stop talking. All you had to do right now is A, B, and C. Don't worry about right now, those of you in the room, don't worry about that homework that's attached. Can you stop? Again, we had this conversation on Friday. Those of you at home, there is a homework sheet uploaded for you. You are not doing number 7. If you read the directions, it tells you that, but you're only doing 1 through 6. I don't have the answer keys, can you please stop talking while I'm talking? I don't have the answer keys uploaded, but I will, so you're working on that, you guys don't have to worry about that right now. Just A, B, and C, we're gonna come back to next period, focus on that project first. Get that out of the way. Good. Now I can start singing and whatever you were doing.
The Seamus is the leading tower of pizza. Here, look, I'll even look up the leaning tower of pizza picture. Let's just, I'll compare it.
Really easy piece of root right here, and then actually go back. So I did this one. I know who would have one system.
Okay, let's go to images. Let's go to images. Look at this. What are you asking? The look.
Oh, wait, are we supposed to look at it?
Not it, but it's the same size as the forehead. Look at Seamus.
They look the same.
People say if you have a big head, if you have a big brain. No, that's different for us. If you have a big brain, you're gonna have a big brain.
Here's a pencil.
It's all
But
good.
Austin says it sounds like one of those remixes at a DJ party.
RJ, like, sounds like a terrible.
I know I'm a terrible reader.
They're white